me see you guys. Hold on a minute. Let me get my camera up here so you can see me. Hello, it's Math Fairy here, and I have a puzzle for you. And it takes on some geometry here. Okay, so, and I will say for this puzzle, if you have markers of equal size or toothpicks of equal size, or I had Q-tips of equal size, or matchsticks of equal size, because that's what they use in the puzzle, get 7 of those. Okay, pause the video, get them, because you'll want to use them. All right. Okay, let me show you the puzzle, all right? Okay, so going here, I'm going to go to my notes app, and I have the puzzle. So drum roll here. It is something about triangles. So here it is. The triangle puzzle. The following, all right, I'm going to read it with ya. Oh, this is the picture here that we're looking at. The following isosceles trapezoid. Whoa, have you ever heard of that? So this right down here is called an isosceles trapezoid. Do you know why? So you might look at it and say, well, yeah, I see the trapezoid. Yeah, it's a trapezoid. But why is it called isosceles? So, well, first, why is it trapezoid? Could you tell me? Do you know? Can you give me any particular reason other than it looks like a trapezoid? The reason is because, see if you can finish my sentence, it has one set of parallel sides. So if I look at, are these two the one set of parallel sides? No! It has the top and the bottom parallel to one another. Okay, so there it is. It's a trapezoid because of that. Now, this other word here is isosceles. Isosceles. So what does isosceles mean? You might recognize it from triangles. When a triangle is isosceles, it has 2 sides that are the exact same length. So do you see why they would call this trapezoid isosceles? Huh? What do you think? I am going to highlight which sides. This side has the exact same length as the other side. Yes. And the ones in yellow are in this trapezoid, the parallel sides. Okay? So this particular trapezoid, we can even be more specific and call it isosceles. All right, enough with the precise geometry talk. Let's keep going. The following isosceles trapezoid is composed of 7 matches. Oh, yes. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 7 matches. You need to modify the position of 3 matches in order to obtain, here comes more geometric terms. We have to move 3 matches in order to obtain 2 equilateral triangles. Oh man, guys, we can only move 3 matches in order to obtain 2 equilateral triangles. So do you know what equilateral triangles are? Let me try drawing them. Equilateral triangle. So equilateral triangles are triangles that have all the same sides. Every side is the exact same length. So the one I drew, this side is going to be the exact same length as this side, which is the exact same length as this side, which means all 3 are equal. So it's called equilateral triangle. Now let me try one that would not be equilateral. I'm going to make that one long, that one short, and that one sort of long. So this one, no, none of the sides are the same. So this is definitely not equilateral. One that you might be used to seeing like this. This side's a little shorter than these 2. So that's not equilateral. So we're going for 2 equilateral triangles. All right, it's time to take out your 7 things that are hopefully the same size. Otherwise, you're going to run into some issues. So I am going to get my camera going. and so you can see what I'm doing. Oh, hi. So you actually need to see my Q-tips. So here you go. All right, so on the couch, I have my 7. And I'm going to set up the puzzle the way we saw it on the screen. I had 2 on the top, 3 on the bottom, and then I had my sides that were of equal length in my trapezoid. Okay, there I have it, my trapezoid. Now, isosceles trapezoid, yeah? Okay, now I need to move 3 of them to make what? Oh yeah, 2 equilateral triangles. Watch this. 1, 2, 3. Maybe I get rid of that one. Now I have 2 equilateral triangles. Cha-ching! No, guys. It's not that easy. You can't just get rid of one of them. Man! Okay, so we have to try something else. Okay, let me put that back here. Now, the thing is, I did notice something, though. When I made my 2 equilateral triangles, there's 3 sides there, and there's 3 sides there. And I have 1 remaining. So, when I make 2 triangles with 1 on each side, that's a total of 6. So that's kind of weird. I can't make 2 triangles with each side being 1. It won't work. I'll always end up with 1 extra. So maybe I try making a triangle with a side length of 2 and see what happens. So what if I keep these 2 down here? And then, oh man, I see something, you guys. Oh my gosh! Pause the video and try and figure this out yourself. But I'm going to move this one because I said I'm going to keep these 2. Okay? So now I'm going to move this like that. Okay? So I moved 1 Q-tip. But I need to move 2 more. Pause the video, see if you can figure this out. I need to move 2 more to make 2 equilateral triangles. I see what I need to do. Do you? You might be like, Miss Eberly, you have another trapezoid. Yeah, I do. I have another isosceles trapezoid. But if I move these 2 somewhere, I will then have 2 equilateral triangles. You guys, don't just let me tell you the answer. Pause the video. Try to struggle through it for a little bit to see what happens. Okay? All right, here we go. I'm going to show you. All right, I am moving this one like this. Ha 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 ha! Do you see what I'm doing? Oh my gosh, so much fun. And this one here. Whoa! Yeah, there are 2 triangles, but they're like within one another. Whoa! So I have my big triangle is equilateral because each side has a side length of 2. And then I have a small equilateral triangle where each side is equal to 1. Wasn't that just oh so cool? Oh my gosh. Good work, guys. Way to go. Hopefully you had fun with a little geometry today. Adios!